All right. Today we're diving into the engine room of the internet. We're talking about server-side programming or SSP,
Mm.
and really this whole exploration is about understanding the hidden mechanics that power basically everything we do online.
Hmm.
Your favorite shopping site, your bank, all of it. Okay, let's unpack this. So what we see as users, that's the client side, right? The interface in the browser.
Exactly.
But SSP is the critical backbone. It's running on a server somewhere far away, and it's just inherently more powerful because it's where all the important stuff happens.
It really is. I mean, to put it simply, SSP is just the code that runs on the server, not on your phone or your laptop. That's what makes the web dynamic.
So how does that actually work?
It's this core process, this request response cycle. It's basically 5 super fast steps. You send a request like clicking a button.
Okay.
The web server catches it. The server-side code figures out what to do, the business logic. Then it grabs any data it needs from a database. And finally, it packages up a response and sends it right back to your screen.
And what really jumped out from our sources is just the sheer variety of languages that do
Yeah.
this job. Each one seems kind of optimized for a different thing.
Oh, absolutely.
Like JavaScript with Node.js, the sources all point to its non-blocking architecture.
Right, which sounds technical, but it just means it doesn't wait around. It can handle thousands of requests at once without getting stuck, which is why it's perfect for, say, a real-time chat application.
And then you shift gears and you've got Python, things like Django and Flask.
Yeah, and with Python, it's all about that clean syntax. The data science community loves it, which is why you see it powering a lot of, smart AI-driven web apps.
Then there's the heavyweight, Java with Spring.
Mhm.
Our sources paint this as the definition of enterprise grade.
It is. It might be a bit more work to set up, but for things that absolutely cannot fail, I'm talking global financial systems, it's the undisputed king for scalability and security.
So the server's doing the logic, but what's fascinating here is that it also has to manage all the data. That means talking to databases.
Yep. And you've really got 2 main flavors there. First are the classic relational databases like MySQL. Think of them like a super organized bank ledger. Everything has a fixed place, a fixed schema, very consistent.
And the alternative, NoSQL.
Right, like MongoDB.
Yeah.
They trade some of that rigid structure for freedom and speed. It's more like a giant warehouse where you can store all sorts of different things. It's built to scale out massively.
So if NoSQL's all about that flexibility,
Yeah.
doesn't that freedom introduce some pretty big security headaches?
That's the perfect transition, because that leads us to probably the single most important word in SSP, security.
And it's not optional, right? Our sources were clear on that. It's like the engine falling out if you don't bolt it down.
It is the absolute foundation of user trust.
Yeah.
And we need to separate 2 ideas here, authentication and authorization.
Okay, what's the difference?
Authentication is just proving who you are, your username and password.
Yeah.
Authorization is what you're allowed to do after you're logged in. And we use tools for this. A JWT, a JSON Web Token, is like a server-signed passport. It lets you prove who you are on future requests without the server having to look you up in the database every single time. It's super efficient.
And that's often tied into systems like Oath or single sign-on, which is great for us as users because we don't have to create another 100 passwords.
Exactly. And all of this functionality, this logic and security, it gets exposed to the world through APIs, application programming interfaces.
That's the gateway for like mobile apps or front-end frameworks.
It's the critical gateway. And while REST has been the standard for a long time, the real insight with something newer like GraphQL is that it lets the client, the app, ask for exactly the data it needs and nothing more. It's a huge performance win.
Beyond just working, though, it has to be fast. It has to scale. For someone listening who's just starting out, when do they need to worry about something like load balancing?
It's less about a specific number of users and more about reliability. You can't have your whole system go down because of one traffic spike. That's where strategies like caching, using a tool like Redis to store common results, and load balancing come in. Load balancing just spreads the traffic across multiple servers, no single point of failure.
And the stakes are just so incredibly high.
Yeah.
SSP is running everything from banking to medical records.
Yeah.
Security has to be baked in, right? Things like input validation,
Yeah.
making sure someone can't type malicious code where their name should be.
Oh, absolutely. Protecting against threats like SQL injection and cross-site scripting is a constant battle. It's non-negotiable.
So what does this all mean for you, the listener? It means the entire foundation of every secure, fast online experience is built on this invisible server-side work.
And if you connect it to the bigger picture, that initial choice of technology, whether it's Python or Java or Node.js, It really dictates everything. It sets the ceiling for your development speed, your security, and just how big your application can eventually get.
That makes me think, given the huge difference between Python's use in AI, where data can be messy and unstructured, and Java's use in highly regulated banking, how do you think the core security best practices have to change when you're dealing with constantly fluctuating data versus static, predictable financial records? Something to think about.